In this session, we're going to talk about zeros of polynomial functions. Is there a E? I don't know. Zeros of polynomial functions. That means the value of x that will make f of x equals 0, isn't it? So the polynomial function, the general form looks like this. A n x to the nth plus a n minus 1, which is a lower by that. And then if you like, you can write one more, n minus 2, n minus 2. It's just a different way of writing. So plus, I'm lazy, so I call this as lazy dots. And then later, I'm going to have a2x squared plus a1, just the x, and plus a0. In this case, my an cannot be 0 because I want to keep this as my highest degree term. And remember, this n is the degree. An is called a leading coefficient. And this, each one, we call that a term. And the last one, a0, is called a constant term. It's just a quick review, okay? All right, now we're going to learn something called rational zero theorem. Are you tired of this? There's so many theorems. What is this? That means if f of x, just like that, okay, has integer coefficients, that means has integer coefficients. Okay. And P over Q is a rational zero of f. Then P is a factor of a0 and Q is a factor of an. So we only care about the leading one and the last one, okay? The leading coefficient and the constant term. What does this mean? This means if f of x has an integer coefficient, that means a0, a1, a2, and all the way to an, they are whole numbers or 0 or negative whole numbers. Okay, so if that's the case, then they're all integers. There's nothing behind the decimal point. Then we can have like a p over q, p, which means a factor of a0, q, a factor of an. If you have a possible rational zero, it must have this pattern. Or what does that mean? Okay, I'll give you one example. F of x equals negative x to the fourth plus 3x squared plus 4. Now, I ask you, what is the degree of this polynomial? Which is 4. So n is 4. Okay, and our a4 is what? a4 is the coefficient of the first term, leading term, so that's negative 1. And what about a0, the last one? The last constant term, that is 4, isn't it? If this guy, or if this function has rational 0, that means it must have something looks like a p over q, and a p should be the factor of 4, and a q should be the factor of negative 1. So negative 1, what are the factors? The factor of negative 1. They are either 1 or negative 1, isn't it? What about for 4? What are the, okay, so this is a4 and this is a0. So the factor of 4. What are the factor of 4? It could be 1, could be 2, could be 4, it could be both positive or negative. So we have 1, negative 1, 2, negative 2, 4, negative 4. That's all, right? That's all the possible factors. That's all the factors of a 4. So we are going to have the format looks like a P over Q, and the P is the factor of A0. P A0 is a 4. So on the top, we could have a 1, -1, 2, -2, 4, -4. And the Q is a factor of an, which could be just 1 and a -1. So what are all the possible rational zeros? So possible rational zero will look like something on top. We choose the number from here, divided by the denominator P and Q, right? So those will be the P, those will be the Q. Okay, so that could be 1 over 1, 1 over okay, let me just write it. Could be 1 over 1, 1 over -1, and then of course we have -1 over 1. You see there's a repeats. So okay, seems like I don't really need to take both 1 and a -1 because I already have considered a positive and negative here. So let me go ahead. I will have a 2 over 1 and a 2 over -1, -2 over 1 and a -2 over -1. If I write, I just list all of them. Okay, so and then I get a 4 over 1, 4 over -1, -4 over 1, and a -4 over -1. If I list all the combinations, it's going to look like this, right? However, there's so many repeats, so I would say I put this just 1, and I put that as -1. Okay, and these two are the same, they're just 2, and of course this 2 is just -2, and a very similar, I have a 4 and a -4. So if I have possible rational zeros, it got to be from this set. Okay, so without solving this fourth degree polynomial, you can just try. You just plug in the number to see which one works, and then if nothing works, then that means okay, there's no rational zero. If something works, then that's it. Okay, so that's how you solve. That's how you use it. And if you graph, then you're gonna see, guess what? Actually, this two are my actual zeros. But usually the question would ask you just list all the possible rational zeros, which is like that, and then you can just try them one by one to determine which one is your rational zero. Okay. All right. Now the next one, I give you this: f of x equals 15 x cubed plus 14 x squared. Did you notice I really don't care about all the terms in the middle, right? So I have a0 that's -2, and the factors are 1 and a -1, 2 and a -2, and an, or the highest, a3, which is 15. Okay, now this is tricky. So what are the possible factors? They are 1, -1, 3, -3, 5, -5, 15, -15. So that's a lot, isn't it? So they have like all the things here, and we have like at least 4 here. Again, so all the possible, again, I'm not saying they are, I just say possible rational zeros. Let me just say that could be, I gotta use this, I gotta use okay, again, P over Q. P is a factor of a0, and Q is a factor of an. See? So the top is a0 part on top could be 1 and 2, and the denominator could be this. So that could be 1 over 1, so that's a 1 and a -1, I'm kind of lazy. I didn't list all of them, but I know if you do that, you have only this 2. And then you're going to go 2 and a negative 2 over 1 negative 1. So I get a 2 and a negative 2. All right. And then I use 1 negative 1 paired with this 3 negative 3. So I get a 1/3 and a negative 1/3. Okay. And then 2 over that, I get a 2 over 3 or negative 2 over 3. And this over that. So I get a 1 over 5 or negative 1 over 5. And then 2 over 5, negative 2 over 5. And the last one, 1 over 15 and negative 1 over 15. Okay. And then 2 over 15 and a negative 2 over 15. There are too many of them. But those are all the possibilities here. Okay, so that's the answer. If I ask you, I think the homework or sometimes in the book, if you see the questions, they ask you to list all possible rational zeros. And this is how you should do it. And of course, if you graph the function or if you try each of them to bring them in the original f of x to see which one will make f of x equals 0, guess what? You're going to have negative 1, you have a negative 1/3, and you have 2 over 5. Those are the actual zeros. Okay, so that's what we need to know today. All right. No, we have to do more. I'm sorry. All right, so once we know this, and there's one, another theorem. Do you like it? Okay. It's called Descartes. This is a French guy, I believe, and that's a silent S. And this guy, okay, Descartes, his rule of science. Yeah, I forgot. This is another very important thing you got to know. All right, now you have f of x, right? And you write an x to the nth, you plus a n minus 1, x to the power of n minus 1, plus da da da, and all the way to this. Okay, now what you should do is, you have all the real coefficients. I want you to tell me the sign of each of them. Okay, so the number of positive real zeros of f is either the same as the number of sign changes of f of x or less than it by even integer. The number of negative real zeros of f is either the same as the number of sign changes of f of negative x or less than it by even integer. This is very, very, it's like a tongue twisting, but if I tell you how to do it, then it's very easy. All right, now I give you one example here. F of x equals x cubed plus 2x squared plus 5x plus 4. This is f of x. Now give me the sign. Give me the sign of, if there's a missing term, just ignore it. But you have to put them in the order from the highest degree to the lowest one. So what's the sign here? Plus, 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 isn't it? That's 1, 2, 5, 4, plus, 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 plus. Is there any sign change? Nope, there's no sign change. What does that mean? That means there is 0 or no positive zeros, real zero. Okay, so there's no positive real zeros. If you just look at this, there's no change. Okay, so there's no positive 0. And then you have to put in f equals negative x. Okay, so if you plug in this negative x here, negative x cubed, which is negative x cubed, isn't it? Because you negative, negative, negative 3 times, which is negative. But here, negative x squared is also x squared, so you go plus 2x squared. And here becomes negative 5x, Remember, you plug in negative x and a plus 4. Now tell me the sign. Negative, positive, negative, positive. How many sign changes? Once, twice, 3 times. So there are 3 sign changes. That means there could be 3 or minus 2, 1 negative zeros. There are either 3 or 1. You just drop down to 1, and then you cannot go down by 2 to get negative 1. That's it. So you stop either at a 0 or 1. So 3 or 1. Okay, is this complicated? I guess. All right, now I would like to give you one more example here. Okay, so I give you this one. If I give you f of x equals 5x fifth minus 4x third plus 2x squared plus x minus 3. This is the f of x. Okay, so tell me the sign. Did you notice there's a missing term here? There's no fourth term. It's okay, just ignore it. So we have positive, negative, positive, positive, negative. Now let's see how many sign changes. Positive to negative, that's 1. Negative to positive, that's another 1. No change here, and there's another change. So there are 3 sign changes. That means there are either 3 or, could be or, that means 2 less, which is 1 positive zeros. Okay, that's how it says. Now, in order to find how many possible negative zeros, we have to find what is f of a negative x. We plug in negative x everywhere. So I get this is a negative to the 5th power is also negative. And then that, I get negative 5x to the 5th. If here is a negative x to the 3rd power, it's also negative. So that becomes a positive. Negative square becomes a positive, so that's plus 2x squared. And here, negative x and a minus 3. Now, the sign is negative, positive, positive, negative, negative. Okay, how many sign changes? 1, no change. 2, no change. So there are 2 sign changes, which means there are either 2 or 0 negative zeros. Okay, so this is how you use the Descartes the rule of signs. Okay, so if you have like the sign of changes, if you have like 6 sign of changes, so there could be either 6 or 4 or 2 or 0. So you have to keep going all the way down to either 1 or 0. How many zeros there? Okay, so this is how many sign changes, and that's all the possible number of whatever positive or negative zeros. Okay, so I think right now you can understand what I'm saying earlier about the theorem. Is very complicated. Let me repeat that again. Let x, I don't have that page. Let f of x equals to this guy, and they have all real coefficients. And then the number of positive real zeros could be the number of positive zeros is either the same as the number of sign changes of f of x, or less than it by even integer. That means reduce by 2 each time. Okay, and the number of negative real zeros, would be, you have to find the sign of f of negative x, how many sign changes, and then from that you go every time you reduce by 2. So you might have 3 negative zeros, you might have 1, because 3 minus 2 is 1 negative zeros. That's this Descartes rule of signs. Okay, so that is all for this class.